Hey everybody! This is the video explanation of the Simple Distillation Lab for RCBC for Organic One Lab. So I wanted to spend a little bit of time going over what is expected of you and maybe try to explain some things so that it is a little more clear in case there's any questions. So since this is the first one of these that you may be doing, you're going to want to watch this video explanation, which is linked right here. And so this is, just so you know, this is a Google Doc. You're going to have a PDF, but it's all going to look the same. It's all the same information. So you're going to watch this video explanation, which is this thing that I am doing right now. And then you're going to watch this lecture video on what distillation is, and you have access to the slideshow in case you want to print it out, make notes, whatever you want to do. Because distillation is one of those things that you don't get a sense of unless it's hands-on or unless you're looking really good. What I did was I went to YouTube and found a couple of videos of simple distillation, what it looks like, how it is performed, and then one of fractional distillation as well, so that you can see what the apparatus looks like and things like that. So, so there's lots of reference material for you so that you know what is going on. Okay, so I went into Professor Sherlock's website and I got the directions for simple distillation. And but if you want to read that, that's found here. It's also in the in Blackboard. Okay, so you can find it in Blackboard. So you go down and you read through this and you find out what the heck is going on. And there's 3 parts. Okay, there's the ethanol and propanol, cyclohexane and toluene, and acetone and cyclohexanone. And so we're not going to obviously ask you to carry out a distillation, but what we want you to do is to become a distillation consultant. Okay, we want you to become an expert, enough of an expert on distillation so that you can help a company. Okay. And so keep that in mind as we go through and answer the questions that we're asking you to answer for this lab. So if you look, the first thing that you need to know, because distillation separates compounds based on boiling point, you're going to have to look up the boiling points of the 6 compounds that the company was using. So there's the first one and the second one and the third one, right? Ethanol and propanol is the first one, cyclohexane and toluene is the second one, acetone cyclohexanone is the third experiment. And so you're going to look up all 6 boiling points, and then I need a reference for which for where you found each of those boiling points so that I know that they're official. Okay, and so then the first thing that you want to do as a consultant is you want to kind of assess how each experiment went. So you're going to go back up to each part 1, and you're going to make an assessment. Do you think that the simple distillation process worked? Do you think it wasn't going to work? And then explain why you think the way that you do based on the information in the lab and what you know about distillation. And you're going to do that for all 3 parts. Okay, and so then you're going to do this, and you're going to take the data that the company, the quote unquote company, had, and you're going to do some analysis, and then you're going to make some recommendations. So the company here did part 3 and got all of this data for part 3. Okay, and so one of the things that you can do is you can calculate the efficiency, and then for each trial, notice you can put the efficiency 1, 2, 3, 4 under here, and then you can average each of those efficiencies to determine if determine exactly how efficient everything was. Okay, and so here's the formula for efficiency right here. Okay, and then A is the low boiling, so you're going to need to know which one is the low boiling, and I is the intermediate, and B is the high boiling point liquid. Okay, and so then you're going to, once you see the efficiency and you look at the data, you're going to make a judgment call. Do you think it was successful? Do you think that the compounds were successfully distilled based on boiling point? And then if you think they were, tell me how you know, and if they weren't, explain what you think went wrong. And then you're going to repeat that process for all 3 parts. Okay, part 2. We're going backwards through the parts. So this is part 2 and then part 1. Okay, so you're going to have to make sure you know this. So now you're going to do some analysis and then some recommendations. So what I want you to do is I want you to look at efficiency of each trial, and then look at the delta BP, or the difference in boiling point for each. Okay, the difference in boiling point you can easily calculate by doing a little bit of subtraction, and then look at the boiling point and compare, or the difference in boiling point to the efficiency. And so that statement that you're going to write in there should look like, as difference in boiling point increases, average efficiency, blah, 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 I don't know, blah, blah, blah. Increase, decreases, stays the same, I don't know. Okay, or the reason why average efficiency increases is because the difference in boiling point, blah, 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 stays the same, increase, decrease, it goes up, goes down. I don't know. So, we just want that statement in there so that you can realize, and so that you can use use that statement to kind of guide you through the rest of this. Okay, and then this question here, it says if the target is to get close to 100% efficiency, how does the relationship above help you make a decision about which type of distillation you use? So the point is that you want to relate this statement that you made up here about delta BP and efficiency to the type of distillation that you're going to use in order to separate these things. Okay, and so now that you've made that connection, you can come down here and you can make a recommendation about what type of distillation that you need to use in order to accurately assess each or accurately separate each part of the mixtures. So part 1, part 2, part 3, it's the same question. Okay, so you're going to answer that question and then make sure that you explain in detail. Okay, that's one of the things that I think students forget sometimes. It's not that you need to be overly verbose. You don't need to like spend hours and hours explaining. What you do need to do is give good details as to why you picked that particular type of distillation. Okay, and just so you know, last thing here is you don't need to pick one for, it doesn't have to be, it's not that one is each, a different one for each one. If there's 3 parts and there just happens to be 3 different types of distillations, it doesn't mean that one has to be simple, one has to be vacuum, and one has to be fractional. Okay, so it's it could be that they're all simple, it could be that they're all fractional, it could be that 2 are vacuum and 1 is fractional. I don't know but that's up to you to decide. Okay, so that explains what you're going to do for the simple distillation lab, and hopefully you like your time being a consultant. Have a great day.